Behind every great product is a great seal. Join us at the crossroads of preeminent product design engineering, seal mastery, and supply chain excellence, and learn from the makers of our future.
Hello, welcome to Makers of Our Future. I'm excited you're joining us today, hearing from people that are behind the products that are changing the world. At Darcoid here, we decided to make this podcast as a searchable store of knowledge, something you can count on when you're speccing your next seal. Let's get started. I'm Bill Sharrett. I'm Senior Vice President of Business Development at Darcoid, and I'm your host for today. Our guest for today is Mr. David Setton. Dave is an accomplished engineer with over 25 years experience in product design and project management. Dave specializes in semiconductor capital equipment applications, MEMS, robotics, and automation. He's currently Director of Engineering at Lam Research, who is a leading supplier of semiconductor capital equipment. Dave, welcome to the show.
Thanks, Bill. Glad to be here.
Good to have you. We were catching up earlier. It's been a very long time since our paths crossed. I've been delighted to see that your career has gone from strength to strength. Currently, you're at Lam Research, and semiconductors kind of in the news as being unobtainable and holding up all kinds of supply chain issues. And I know there's a ton of investment going into bringing new fabs online in the US. So how's things from the big picture industry perspective?
Yeah, things have been really good for the past decade or so in general for semi equipment. And as more items around the household have more semiconductor content, the business has been growing pretty well at Lam. We're facing a lot of the supply challenges as well as other industries at this time. So there's a huge surge in demand, and we're trying to keep up like everybody else, which is, it's kind of crazy times in general. So
you get busted. You get busted if you use the word unprecedented, because I think that's a little too used these days.
Yeah. But it really is. It's, for semiconductors, dishwashers have semiconductors now. And obviously all our devices, phones, have the semiconductor content in the phone is going up. And now everybody, lots of people have multiple phones. I have a work phone, you have a personal phone, kids have phones. Multiple laptops in a household, the TVs and the cable boxes, etc. Refrigerators now come with semiconductors in them and are Wi-Fi enabled, microwaves, I guess. And then cars, have a tremendous amount of semiconductors in them today as we get into Wi-Fi and self-driving and autonomous vehicles and things like that.
Oh, shoot. Yeah, I mean, you jump on your bike, right? And it's like, do I use my bike computer? Do I use my phone to upload to Strava? Do I use I've got a radar on the back, to tell me when people are coming up behind. It's chips everywhere, right?
Yeah, and even bicycles have electronic shifting, power meters. I have a few bikes that have power meters on them, which have chips in them. Everything's Bluetooth. Yeah. So,
well, Dave, hats off to you for single-handedly making that all happen. What a guy! You must be busy.
I'm on the supply side and the demand side. Yeah. I'm a whole economy into myself, right?
So, how many's on your team? As Director of Engineering, what does that look like in terms of managing people as well as projects?
So I've got, I think 11 people on my team, 2 separate teams. One team is doing system engineering and one team is doing configuration engineering. So, I think 11 people. And then I kind of dotted line manage a couple program managers on specific projects. So it's busy, it's fun, great team. Really proud of them on all the work they've been doing. That system engineering team has mostly been on site through the pandemic, and they've been, kicking butt and taking names for a couple of years and making stuff happen.
Yeah, excellent.
So really proud of that team. Everybody's doing well.
So in terms of engineering, do you get to do engineering anymore? Or is it people management? Do you wake up in the middle of the night and say, aha, this is how we're going to do it? I mean, where's the creativity versus management kind of?
Yeah, a lot less on the creativity side, which I miss, to be honest. But I still have a little bit of input. When the team gets stuck, I kind of dive in and try and help. It's not too often, but it happens on occasion.
Yep, excellent, good.
I still have some value. I'm happy to report. They might not think so, but I still think so.
Good for you. So let's roll the clock back. I was looking at your bio on LinkedIn, and it looks like you got out of school about the same time I was getting into the steel industry, sometime late last century. What was your path? You were UC Santa Barbara, yes?
Yeah, mechanical engineering at UC Santa Barbara. And I actually went to work for Lam Research after that. I was an intern in my senior summer at Lam as a manufacturing engineer. Worked for Lam for a couple of years in manufacturing engineering, a little bit of design work in the gas box and gas delivery space.
Okay.
And then went to Matson Technology. I think that's where you and I crossed paths.
Yep.
In 96 timeframe or something like that. Wow, way back then. And then was at Matson Technology for a few years, and then went to graduate school for my MBA at UC Davis. And then back to Matson after that.
Great. So graduate school, that's a big step on the educational path. Was it a big benefit for you in terms of your career, in terms of how you approached the projects you're working on?
It was certainly fun while I was at business school. I really appreciated being a full-time student. I decided to leave industry and go back full-time. Semiconductor was boom or bust. And so I didn't think I could handle a full-time job and part-time school. So I decided to go back full-time, and it was certainly fun and certainly educational, and I enjoyed it. Compared to my undergraduate days, I was really focused on school in graduate school versus, being 18 at UC Santa Barbara. I think school
beautiful
was
school.
Yeah, amazing place. I think school was like third or fourth priority, So I was really focused, and that it was awesome. And so I think it helped my career. It's hard to say. I've been very fortunate in my career and enjoyed my work, so I'll say yes, it was worth it.
Cool. Good. And you did you're self-employed in the mix there. Setton Consulting, what were you working on then? What kind of scope of projects were you handling?
Yeah, so as I just said, right, the semiconductor equipment industry was often boom or bust. And so in some of those bust times, I decided to go out on my own and work on projects. And it varied. Sometimes I was working as a mechanical engineer. Sometimes I was working as a project or a program manager. Sometimes as like a technologist. So, really depended on what the customer needed. And I was flexible, and that was super enjoyable as well. I had a little bit more flexibility in terms of which projects I worked on and which customers. And so that was super fun, educational as well. Seems like a different lifetime ago.
Yeah, I I'd forgotten about that boom bust cycle on semicon, and we all watched the book to bill ratio as, that was going to tell us how things were going. And it was pretty savage there. So good move. I mean, do you have to do a lot of marketing and promotion when you're self-employed, or was it referrals and networking?
It was mostly networking, right? I had a past coworker that was sort of the rainmaker. And he would kind of bring in the projects, and for the most part, there were a couple others that were from contacts back in the Matson days or previous Lamb days.
Excellent.
Yeah, so it varied, but mostly I had a kind of a business development guy who was feeding projects.
Excellent. So
and surprisingly busy, during those times.
So you really got to pick and choose a bit. I mean, it's nice to have that luxury.
It was. We were super busy right up until the Great Recession, right until 2008, where everything kind of, that seems like a lifetime ago, doesn't it? 2008, and where everything dried up rather rapidly.
Yeah, it was staggering how things shut down and stopped. Yeah. Scary Mary. Tough time for everyone. You mentioned the word intern earlier, and that's interesting to me. We host interns periodically in our engineering group at Darcoid. Do you have experience managing or working with interns since being an intern yourself?
Yeah, at Lamb we do have some interns. It's actually been quite competitive. For summer interns, interestingly enough, I had a friend who wanted to have their, I'll say kid, high school, entering college, do some intern work. And, applications have to be in the prior winter for summer work. There's a lot of competition for them. I personally haven't managed interns, but the quality of the work that they produce, I've seen it and I've worked with them, is very high. I'm super impressed with kids in college these days. I should say young adults. They're not really children. Very hard workers, very sophisticated, quick learners. Really impressed with their work that I've seen in the recent past.
Excellent.
Probably way better than I did as an intern.
Yeah, I mean, sometimes it can be a make work kind of a program, but when you have real defined desired outputs, that can be a game changer. What should an intern know? How should they make the most of their opportunity if they have an internship at Lamb? How do they stand out? How do they get an invite back for a full-time job?
Yeah, that's a good question. I think, I think the public speaking part of it, the presentation part of it is really important. That's where people really see kind of where the rubber meets the road.
Okay.
So it's unfortunate that because that's not a strength for a lot of people, especially engineers. And I think that's the case for not just interns actually, but for young engineers and even managers. The ability to present in a clear and concise manner is a challenge, right? A lot of engineers dig into the details too much. So a lot of people could do, like for the interns, for example, they may do great work, but if they can't present it, it's not known, all the great work that they do. It's kind of hidden, especially to the executives. So if they can present themselves and their work in a very concise manner, but still get their point across, and also be able to deal with the details when those questions do come up, I think that's a real advantage for them. And I think that's for young engineers and managers as well, being able to articulate their ideas and their concerns and the risks to management is super important.
Now that's really, actually, it's really good to hear because as a parent of kids going through high school and then into college, they spent a lot of time on group projects with an emphasis on presentation. And I always kind of wondered about that, but those points really drive home the value of being able to speak to the whys and the results and the achievements in the presentation material. Good stuff. Thank you.
Yeah, sure. Yeah. It's a skill. It's a skill worth learning, and it took me a long time, me personally, to understand that. So I think it's a real advantage if people can come up to speed quickly in that area.
It's that balance between I really want to tell you everything I've done on these 17 slides versus death by PowerPoint and getting that right.
Exactly.
All right, so this should be about seals. So let's talk about seals. Was seals taught in school when you left Santa Barbara as a qualified and dangerous ME? Did you know anything about seal or elastomers?
No, I knew zero. And actually, here's a good point. Like, I thought Santa Barbara was a good school, and I still think it's a good school. When I was a manufacturing engineer, I knew very little. I came in so green as to what a number 10 screw was, or what a seal or an elastomer or an O-ring was, or how it worked, or how to design. So there was a lot of on-the-job education for me coming out of a theory-based school like Santa Barbara. So the short answer is I didn't know anything about seals.
I'm gonna have to hit up the faculty. I've got to see if they should come on the show and expound on that because it's it's a specialty industry, it's a specialty application, a specialty field, but seals behind everything. It's an important thing to know about for sure. So we talked seals at Matson, right? I think we were talking earlier, trying to remember what we worked on together. But was that your first run-in with seals at Matson Technology?
For sure, from a design perspective, I went as a manufacturing engineer at Lam. I'm sure I dealt with them in some capacity. I don't recall. But from a design perspective at Matson, and the application that we worked on, that you helped me on, was a vacuum robot for wafer transferring in the transfer module we were designing. And we had a very large shaft. It was I think a 6.5-inch diameter shaft that we were trying to seal on a rotational basis.
So, we applications, I mean, vacuum is the name of the game in process chamber environments for etching designs into silicon, right? Vacuum robot. So normally if you got a vacuum, the seal you'd use would be something that's completely impermeable, and you'd squeeze it nice and tight. The trouble is when you do that, you can't move the mating surfaces, and that robot doesn't rotate like you want it to. So you get into some design challenges right away, right?
Yeah. So we had, if I remember back in the day, we squeezed too tight, like you said, and we didn't have the torque in the motors to rotate the shaft. We also had a lot of particulation, which is a problem in semiconductors. Everything's got to be very clean. So we didn't want that particulates. We would also wear the seal very quickly so that it would have to be replaced. And you don't want a lot of downtime in semi equipment. You want to keep pumping out chips.
Well, so those were the initial. As a seller of seals, I recommend replacing seals every day if we can. But,
but then they never get used if you're replacing it. We struggled a little bit with that. So we started, I think, with O-rings. We went to a lip seal, and that worked well, except it would wear the shaft. I can't remember the material. I think it was a high carbon lip seal or something like that would wear the shaft quite extensively. If I remember correctly, we had a chrome plating on the shaft, and so that didn't work out. I think the final solution was 2 quad seals with a differential pump in between. It was the final solution, and with lots of vacuum grease.
Lots of grief. Yeah, it's one of those edge case applications where there's nothing in the manuals, nothing in the books, nothing online will tell you how to do that. And material science, and do you use Teflon? Do you not? That's where stuff gets interesting for sure. So, Dave, can you step back a bit and give me a kind of a fly through on not how a semiconductor is made, but what does a process chamber environment do? How is the wafer moved around? How is it exposed to chemistry? How does it all fit together?
Yeah, so
in 10 words or less.
In 10 words or less. Let's see if I can my public presentation. Yeah, so I'll talk about modern wafer handling.
Yep.
And I describe it to lay people as kind of a high-tech pizza oven. Think of the wafers. So chips are made on wafers. They're about 1 foot in diameter, like a personal-sized pizza. They come in a box that's sealed, and it goes into an opener. It opens the box, right? I mentioned everything. Excuse me. I mentioned everything has to be super clean. So inside these plastic boxes, the personal-sized pizzas, the wafers sit in there at 25 of them. It gets opened. Everything is super clean. It gets picked up by a robot. It has like a spatula. If we use the kitchen analogy some more, it gets picked up by a spatula.
End effectors, right?
Makes it. I'm sorry?
End effectors? Is that?
Yeah, that's what we call the high-tech word for a spatula, end effector. And these pizzas get baked in a vacuum. So you have to take them from the box, which is at atmosphere, although it's a clean atmosphere, into the vacuum. And so we have a transfer module is the name of it. And it takes, it'll take the wafer, put it into a load lock, which then is evacuated. All the air is removed. And then it gets transferred into the process module, which is the oven. And there's a variety of different types of ovens. Lam has a couple specific types. One was we etch, which removes material. We also have depth tools or deposition tools, which we add material onto it. My background is more on the etch side. And so in these high-tech pizza ovens, we either heat the wafer or sometimes we cool the wafer to sub-zero temperatures, depending on the application. We apply a lot of energy and gases, different etching gases, and there's a range of them: chlorine, bromine, SF6, a variety, O2, oxygen, argon, nitrogen. And so with these gases, it then etches the silicon wafer.
And it's just about everything else that it can get exposed to, right? I mean, some nasty chemistry there. Very aggressive, aggressive.
Correct. There's some aggressive chemistries. It etches the silicon, it etches the seals.
Yep.
It etches the interior of the chamber. So Lam does a lot of business in consumable parts. Think of it kind of like the tires of your car, right? They wear out and we exchange them. And or maybe the motor oil of your car or something like that, which gets exchanged every so often. And so the wafer gets baked, the pizza gets baked, and then gets removed out of the chamber, and it goes back into its box, and then it goes on to the next step. And in making a wafer, there's 30, 60, 80 steps sometimes on the latest technologies. Half of them are etch, half of them are dep, and then there's a few percentage of other things in there too. So that's kind of the high level of a wafer processing equipment or semiconductor processing equipment.
Super, thank you, awesome. So from the seal side of things, I guess the closer you get to that process chamber environment, the cleanliness requirement ramps up and up and up. So you described aggressive chemistries, fluorine chemistries. I mean, that's to etch glass, you need fluorine. Fluorine breaks down the polymer bonds in the elastomer. The elastomer starts degrading. Whatever else is in amongst those polymers becomes something that can get close to your wafers during processing. So a lot of material science on the seals, right?
Yeah, actually, the seals have a lot of jobs. Obviously, they have to seal, and you require elastomeric properties, right? It's got to be flexible. And like I mentioned, there's heat, there's cold temperatures, temperatures cycle quite a bit. So the main job of the seal is to seal and keep atmosphere out of the vacuum side. So that's number one. And then, as you said, it's got to remain clean and not etch or be etch resistant. It's got to not harden so the seal can remain. It can't expand too much. It can't absorb material and expand, because then it'll change the sealing properties and we'll have leaks. It can't expand too much with heat or contract too much with temperature. So a lot of challenges for that seal. And also in these aggressive chemistries, if it erodes, it'll stop sealing. So yeah, tons of technology in there. It's a super critical part in our process equipment. It remains one of our challenges to have a seal that lasts a long time, right? If we go back to our motor oil analogy, right? We used to have just regular motor oil that would last 3,000 miles. Now you have a synthetic motor oil, which lasts 10,000 miles, which is kind of a game changer for the automotive industry. We do the same thing. We want our seals to last a long, long time so we can keep the equipment up. And there's been huge strides with the new materials in recent years. And I'm not a seal expert in terms of the chemistry and things like that, but we've gone to much better materials, and they last much, much longer compared to when I was first starting out in this industry.
Clean burning, long lasting. That's the name of the game, right?
Exactly. And low particulation, as you said, low erosion rates. It's been real key to extending what we call the MTBC, mean time between cleans of our chamber, right? So once the seals get to a certain point and they're no longer sealing or they're creating particles, we have to exchange them. And then once you open up that vacuum chamber, you have to clean it and other things like that. So currently the seals in some of our equipment are the limiting factor in that MTBC.
And the name of the game for your production equipment in fab is continued uptime, getting the maximum return on investment on that piece of equipment, the maximum throughput, and then staying up with technology advances and etching smaller and smaller device features, right? So it's got to be a constantly moving. The goalposts are constantly changing on that, right?
Absolutely, right. It's got to be cheaper, faster, and better, which is super hard. And that's, thankfully Lam has been, on the leading edge and really making strides and really doing well with our customers. So it's been good for Lam and me personally. But it's a challenge, right? All the powers and the temperatures are going more extreme. We're either going colder or hotter. We're applying much more power to etch faster. Right? The throughput has to go up, and that's demanding of all the materials, including seals in the chamber, and it's creating higher demands for new materials, new technologies, new designs.
Any number of specialty expertise needs to be built in a number of different fields, obviously. And so what advice for a new engineer dealing with seals for the first time? Obviously, Lam has companies like Lam have built up tremendous knowledge and will have a lot of in-house expertise. A lot of the customers we work with don't have the luxury of having that depth of engineering know-how. Engineer first time dealing with seals, what do they need to know, or what pitfalls do they avoid, or how do they go about it?
Well, two things. I mean, find a good supplier like yourself, Bill. Like, you were very helpful back in the day. And look internally to your peers and your elders, I guess. I don't know what the right term is, but people who've been around the block for advice. But don't, also be creative. Don't get stuck. If someone says you can't do that, my advice is be creative. There's always, where there's a will, there's a way. So I think creativity and working hard, it will get you very far. That's Excellent. Been kind of my MO.
Excellent.
Seems to be pretty, I've done okay, I guess.
No, there's always got to be another way. There always is another way. Some of it is almost counterintuitive sometimes, the approaches that you need to take. So yeah, I'd say don't rush into it with a fixed mindset. That seems to be a common theme that I'm hearing in these conversations.
Yeah, I mean, I think you got to be reasonable, right? You're not going to, whatever your spec is, you may not double it, right? If you're looking for let's say my challenge is like a throughput or an etch rate.
Yeah.
We often don't go from 10 to 20, but you might go from 10 to 12 to 15 to 20 over a span of years.
Yep.
And the same thing with a seal, right? You might not get a lifetime out of a seal. If you look at cycles or RF hours or something like that, you're not going to double overnight. But if you have a longer term view, you'll get there. And you got to be creative, right? And willing to try different things.
Excellent. Excellent. Do you think, Dave, career stuff, you're going to stay in the field? You're going to specialize in more discrete technologies? Where do you think you're going? You're in a really good place right now. Where do you see yourself in 5 years?
Maybe retired. I don't know, Bill.
Lucky guy.
I'm playing the lottery these days. Yeah, I think Lam and the group I work in, I work in the customer service business group. We do a lot of specialty markets compared to my peers and other groups, right? We work on MEMS devices, power devices, not your typical logic or memory where the bulk of the business is. So I figure I'll still be in that role for the foreseeable future.
MEMS
but it's a new world, right? With Zoom calls and electric cars and self-driving, who knows where the future will go.
So I remember MEMS was, I don't know when, but back in the day, MEMS was the next big thing, right? Is it still, where do you see that?
Still the next big thing.
It is? Okay, good. All right.
Well, I mean, I use that, kind of tongue in cheek here because it hasn't blown up like they thought it was, at least in terms of equipment side. And I think the challenge is the devices themselves have gotten so small. The microphones on our phone, I'm on an iPhone here.
So that's a MEMS thing, is it?
That's a MEMS thing. The cameras, all those things have gotten so small that they fit more and more on a wafer. So you don't need more equipment.
Oh.
Because there's so many more on a particular wafer.
Right.
And the yields have gotten so good, right? Before it was 50 or 60% of the die would actually be usable. Now they're talking 98, 99% of the die are.
Wow.
You know, and that's kind of our own detriment. We've become so good at producing them on our tools.
You find yourself out of a job.
We're not selling as many tools.
Yeah. Yeah.
It's good for our customers and it's good for Lam ultimately. But I mean, that's part of the semiconductor process in Moore's law, right? Everything keeps getting smaller and smaller. The yields get better and better. They get cheaper and cheaper. So it benefits the consumer, it benefits our customers, and eventually it benefits Lam. But
well, hey, you know, thanks for being a part of that process. I know it takes many to get there, but you know, stuff we can do on these things, oh my God, it continues to improve. So again, hats off to you, Dave, for being a part of that value that's happening.
Yeah, it's a huge team, right? Not just sorry, I got a little reminder there. It's a huge team between Lam, our customers, the engineers. It's quite amazing how many people work on these devices and the progress that we've made over the years.
Fantastic. You got a reminder, my phone pinged too. I realize we're at time. I need to respect that. Couple of quick questions, if we can. Number one, shameless self-promotion, Dave. Often companies are looking to hire the best and brightest. What is about Lam that is the best place to be, and how should people reach you if you want to be available to that kind of approach?
Oh, yeah. You know, I think the best thing about Lam is its culture. We're data-driven. We have very good core values. I think there's a list of 5 or 6, and everybody really plays to those core values. It's a very strong culture, and it's a good culture. It's strong in a good way. And so I think that's the best part about Lam. How to reach me? I am on LinkedIn, David Setton, Setton. Send me a note if you're looking for opportunities. Always hiring. Lam's been growing for the past 12 years since I rejoined. So
fantastic. All right. Thanks
you for
that. Last question. I like to say we stand on the shoulders of the giants who came before us. As you look back at your career, are there mentors or people that have given you advice that has stood you in good stead throughout? How would you like to reflect on that?
Yeah, absolutely. And there are probably too many to name. And I haven't thought about this question, but there's probably 3 people that give me advice that I remember specific, or gave me opportunities or advice. One was my brother. At some point he said, take your graduate school entrance exams in undergraduate because you'll be in the mode of studying. And those are good for 5 years. So that was a piece of advice he gave me, and I give that to young adults these days. So take your entrance exams early. Another one was a close family friend who's now passed, a gentleman named George Kaminsky. He gave me that internship at Lam many, many years ago while I was still in college. He was a nice, great guy, super smart. And a couple pieces of advice, which I also give young people, is take advantage of the ESPPs if your companies offer an employee stock purchase plan. Invest in that all you can. It's awesome.
Yeah.
And that's worked out well for me, and I give that advice. Also, 401k, take full advantage from day one. You won't regret that as well. And just put that money away for retirement. You'll never miss it as you start your career. And then another gentleman, Fred Tabrizi, which I worked at Matson. You probably remember that name.
Yep.
super smart, great guy. I haven't been in contact with him in a decade or so, unfortunately, but he gave me lots of opportunity. He was trusting in terms of my work. Was open to creative ideas. Was critical when appropriate, and I miss working with individuals like Fred.
Outstanding.
Yeah.
Dave, thank you. And there was some really grown-up advice in there.
Well, I am grown up these days, Bill. Unfortunately, I wish I was younger, but at least, as we get older, we hopefully gain a little wisdom.
There it is. And
yeah.
Dave, you shared a lot of wisdom here. Well, it's a searchable trove is what you've given us, and I hope it pops up on people's screens. I think it will. I really can't thank you enough for your time.
Thank you for having me. This was super fun. I'm glad to catch up with you, Bill, and hopefully this is not the last interaction we have for another decade.
It will not. Thank you, Dave. Thank you for your time. That's great.
No, I really appreciate it. Thank you.
Thanks for listening to the Makers of Our Future podcast. Behind every great product is a great seal. Learn more about how we can help at www.darcoid.com. That's DARCOID.com. The best seal, on time, zero defects, Darcoid.